Hello everyone, in this experiment I'm going to calculate the internal resistance of a battery. That battery consists of 6 volt, it forms of 4 1.5 volt cells. Let us restart. We know that the electromotive force of the battery, denoted by E, it is the terminal voltage plus the lost voltage because the internal resistance of the battery. So we can write E equals VR plus I R small. R small is the internal resistance of the battery. Rearrange this formula, so we move IR or shift it to the other side. So we write E minus IR equals VR. Or we can write V equals negative IR plus E. This equation looks like Y equals mx plus c. So m is the gradient. We can rearrange this to get negative Ri plus E. So this is Vr. When we compare between that two equations, 1 and 2, we can say that m is negative R when we represent the graph of Vr. So the graph of V and the current, when we represent that relation, so we find that the gradient equals negative R. The gradient, it will be negative. So when we plot the points, we will get a graph like this. So when we draw the line, the best fit line, so C here, C, it is y-intercept. It will be equal to the electromotive force. So this is E. So, and the slope of this line, the slope denoted by M, it will be equals, okay, negative R. So we can calculate also the internal resistance of the battery. So what we do now, we start the practical and we plot the graph between V and I. And we find the slope from the graph and the y-intercept, which represents E, the electromotive force. Let us start the practical. The apparatus, 6 volt battery, variable resistor, connecting wires, digital voltmeter and digital ammeter. We started to connect the circuit as shown in. Now just we connect here. It is the simple circuit without connection of voltmeter. Now we connect the voltmeter parallel to the battery. We started to take the reading, change the variable resistor to get 6 readings of voltage and the current. That are the reading of current and voltage for 5 trials. Now plot the graph of voltage V against the current. Because the current is very small, we can multiply by 10 and divide by 10. That is the current. Okay, we multiply by 10 and divide by 10. That are the points here. When we plot the points, that are the points here. Now what we do, we draw the best fit line. This is the best fit line. From the best fit line, we can find the electromotive force of the battery, this point, and we find the slope of this line to get R, the internal resistance of the battery. From the graph, the y-intercept, which represents the electromotive force, it's 5.9 volt. And the slope, it's y2 minus y1 over x2 minus x1, but remember we multiply by 10 power negative 1. We calculate the slope from this relation. The answer of the slope is -1. So the internal resistance minus R equals -1. So the internal resistance of the battery is 1 ohm. What are the sources of error in this experiment? The connection here of the battery is not perfect. Maybe we have loose connection. Also a lot of wires. This is another error. So the wires have resistance added to the external resistance. What about the conclusion? We did this experiment to calculate the internal resistance of the battery and the electromotive force of the battery. By plotting the graph VI graph, we found a straight line. Y-intercept of the line represents the electromotive force. It was 5.9 volt. And when we calculate the resistance from the slope, it was 1 ohm resistor. I hope you understand this experiment. Thank you.